I have here with me a Voltcraft LPS 1305 bench power supply. So basically Voltcraft is an in-house brand from Conrad, and they make various bits of equipment, electronics equipment, at a relatively budget price, and I thought that I would buy this because, I mean, it was so cheap and it was only 30 euros. And I'll get into a little bit later why it was so cheap. But yeah, I mean, I don't have a bench power supply, so I thought it would be really great to have one for my projects and stuff. So yeah, I just thought, yeah, why not? So let me quickly first go through the specs. It outputs a maximum of 30 volts at 5 amps, and it has a maximum wattage of 150 watts. It also has a residual ripple. Basically that means how smooth the output is, of less than 5 millivolts RMS, and a control stability, which also means how stable the output is under load, of 150 millivolts an hour. I'm not exactly sure where the hour comes into that, but yeah, I mean, it's really minimal, I would say, and for my projects I think the output is pretty smooth for what I need. You know, I'm not dealing with like super fine voltage critical you know, components, I would guess. So yeah, I mean, I think it's going to be totally fine for what I need it for. It also has like current limiting features as well, so I can just press and hold this button here and change the current output to what I want. I can let it go, and then that will basically be my current limitation, and it won't allow it to go any higher. And it's also got coarse and fine voltage knobs as well, so I can change the voltage coarsely, so like right the way up, and then just finally adjust it with the fine knob. So let me go into the reason why this was so cheap. The reason why this was so cheap, because normally this is a 130 euro unit new, is because it had the problem that when you turn the voltage knob, the voltage display showed the numbers rising very slowly, or sometimes it would even go backwards, so the voltage would slowly drop down to 0 and then it would come back up again, which I thought was quite odd. So I was poking around a little bit, and I discovered that when I probed the output with my multimeter, the voltage on the output would actually be correct, and it was actually very accurate too. So I wasn't exactly sure what was going on. I did, however, manage to fix this, but unfortunately, obviously, it was off of camera, by removing a connector on the display board and plugging it in again. So I'm not exactly sure how that fixed it, but in any case it did, and it was probably just a bad connection. Anyway, I thought it would be interesting to take it apart and have a look inside and show you what I did, and I also did a couple of, just a few little mods to it, so maybe you'll find that interesting. So I'm just going to turn it off, obviously, because I don't want to electrocute myself, and disconnect it from the mains. So there are a lot of screws in this. I say a lot, there's quite a few. So there's 1, 2, 3, 4, 5, so there's 10 screws on both sides together, and then there's just the 2 on the top as well. So yeah, basically, I don't know if I mentioned this in my previous videos, Conrad is an electronics store, and you can buy, or they have like a section in their store where you can actually buy like goods that have been returned. And so obviously, me being an electronics fanatic, I have a field day in there. I think it's great. You know, you can buy stuff like this that's actually pretty good. super cheap because the screwdriver's not working too well for me. Yeah, because people bring them back and they say, hey, yeah, it's not working, I want my money back, or exchange it for a new one. And before I round that off, let me get a screwdriver, another screwdriver. Yeah, so instead of having a look and trying to resolve the issue, they just take it back and get their money back or exchange it for a new one, and then they resell it, and people like me end up buying it. Of course, it's not good on the bank balance, but yeah, I mean, it's interesting, something to do, bit of fun, you learn stuff, and yeah, I mean, you can never learn too much. So now that I've taken those 12 screws out, I can slide this back and it reveals the innards of this power supply here. So there is a huge toroidal transformer there. So let me just zoom in a little bit. There's not much light in this room, but I'll try my best. Okay, so inside is relatively clean. As you can see, it's not dirty, it's actually okay. On the back of this board here, it's a little bit chalky looking, but I mean, it's absolutely fine. So yeah, I mean, the inside looks relatively clean, or at least some of the connectors are glued into. So that one's glued in, and yeah, that one up there too, but this one isn't. This blue one here, this little blue connector, and it was this connector that I pulled out and then just put it back in, and then all of a sudden it just worked. But other than that, I mean, the wiring is pretty tidy. There isn't actually much to it. It's just a very compact looking, power supply. So yeah, like I say, it's got a huge toroidal power supply. They are great at supplying very smooth and linear power, as opposed to the traditional transformers, the great big blocks. A common fault is that I've seen online, because obviously I did some research into the problems that this could have, and I've seen a lot of people mention that the transistor, which is T101, which is right, let me zoom in on the camera so we can see it. It's this small one right there. So this one here, this one tends to fail, and the result of that is the maximum output current tends to be very low, as in like 200 milliamps or there around that figure, or non-existent. And so if you're having that issue and you've got one of these power supplies, yeah, I recommend that you change this out for a new one, obviously. Yeah, basically that transistor acts like an overcurrent protection switch. So when you short the leads out, it will shut the output off, and obviously then you won't blow any of the components apart from the one that's protecting everything, apparently. So yeah, that's basically the reason why that blows, is it's just very weak. So let's get into the interesting part, which is basically what I did to make this, I would say, probably a better power supply. I didn't do too much, but maybe you'll like it. It's really simple, it involves nothing in special, but on the right side here of the front panel, so the right side facing me, there are these two pots here, and one is for the voltage, which is the top one, and the other one is for the current. And actually you can turn those pots, and I've managed to raise the output, its maximum output, so it can go to a maximum of 32.5 volts, and it can have a maximum current output of 6.5 amps, which is 1.5 amps above the stated output, and 2.5 volts above the stated voltage. So I thought that was pretty cool, and you can just adjust them there with a small flat bladed screwdriver. You can't really see it too well because of the camera angle, but yeah, that's there. So basically that was the mod that I did. And also, if you want to check the accuracy of the output as well when it's turned on, you can just change those two pots there. So one is for voltage, which is okay, so this one says current underneath and that one says voltage. So this is for the voltage and this one's for the current, and you can just finally adjust those. So what I would like to do is adjust the accuracy of my power supply, because I have a new set of leads. I bought these also while I was shopping around. So I have a pair of measuring probes. They're still in the bag. Let me just pop them out. And they are also made by Voltcraft. And the leads are, relatively long, which is nice. I'd say they're about 1 meter. And they are rated for, can't really see that. So they are rated category 3 at 1000 volts and category 5 category 4, sorry, at 600 volts and 10 amps. So yeah, I bought those, and I thought these would be really cool to be able to plug into the power supply, because it means then I can just probe around parts of the board. But also I need to make these. I haven't made them yet. I bought some wire and some banana jacks, and I have some crocodile clips to go on the end, and I can use the crocodile clips as well as the probes, and I can mix and match. I can use them both together at the same time, because it means I can use the crocodile clips for the earth, and I can just use a probe to pin on certain areas that I want to test. So yeah, but basically what I wanted to do was adjust the accuracy of the output that is on this display here to what's actually coming through this lead, to account for any losses. So I'll show you what I'm going to do. I'm going to gently plug this in, and what I'm going to do is get my multimeter here, but I'm going to take out the probe from in the multimeter because I want to try and make this as accurate as possible. So what I'm going to do is put my probes, which are here, and try and probe the input of the multimeter, which I don't believe I can do. It would be nice if I could, but I don't believe I can. Will it reach down in there? I think it might. Have to give it a try. So that's basically how I'm going to check its accuracy, and also I can then account for any losses at the same time. So let me turn this on and we can give this an output. Okay, so it's dropping slightly. It was showing some voltage there, but see, now it's gone slow, and how it's rising very slowly now. I'm not sure why it does this, but it did this the last time. See what I mean? So actually, let's see if we can rectify that again. Let's just take these probes out. Does that make a difference? No. But let me just move this out of the way. We're going to try and fix this again. So I'm going to take out this blue connector and very gently, because it's on, and this is what I did the last time it was on. So this will just kill the display, and then plug it back in. Let's see how it is now. And now all of a sudden it's absolutely fine. Yeah. So yeah, it's working okay now. Alright. So anyway, let's carry on with the checking the accuracy. So I'm just going to grab this and put my multimeter on there so we can actually see this properly. And yeah, let's get some light on there. Okay, the light was there. So I'm going to turn the course voltage up to a round figure according to the power supply, so 13 volts here. And I'm going to put my negative probe in there, my positive probe in here. Whoops. Okay, it's a little bit awkward because I have to kind of grab the sides. Oh. Okay, so it's 12.98, and now the voltage on the display has also dropped by 0.1 volt. It's actually pretty accurate. Let's change this. Change this down to 20 volts. Okay, so I have to change this on this multimeter there. So the multimeter is showing 20.1, but the output on the display is 20. Okay, let's move it up a bit. Let's just budge up the amps. 29.1, okay, so it's, yeah. And then I can go past up to the 32.5 volts, and it's showing me 32.1, sorry, 32.6, so 0.1 of a volt over. So that's pretty cool. And yeah, it's set at 6.5 volts, and see how the output has turned off now since I pressed the current limit button. It does this, and then when I let go it comes back alive. So yeah, so it's actually accurate. I did already do some kind of adjustment with the output before. I did do some kind of adjustment with the voltage on the display already to get it, you know, accurate to my multimeter, because this is the multimeter that I'm going to use for when I'm obviously working on my projects and things. So I know then that this, if I use a different multimeter, I guess then it would give me possibly a different figure. So it's always good to use the same equipment that you calibrate your equipment with. So yeah, I will use this multimeter because this is the multimeter that I use to calibrate the voltage that is stated on there. So when I look at this and I look at what's being read on the multimeter, I know then I can account for how much losses that I have, which could mean that it's okay. Or if I'm getting a straight circuit, it means without any losses, it means then that you know, there's a short circuit somewhere or whatever. So basically that's why. But yeah, I thought you'd be interested in this anyway, this video. You know, modding the output of this Voltcraft power supply, and yep, how you could also change or calibrate your displays, and just a quick look inside. I just thought it would be quite interesting for you. So anyway, I hope you liked the video, guys. I'm going to put this back together, and yeah, I'll see you on the next one.